Okay, so the first concept that we are going to discuss is the concept of work. And we are going to talk about the work done by a constant force. So that's the first thing that we're going to discuss. And the definition of work done by a constant force is given on slide 3, which is where I am. Okay, so here's the definition of the work done. Suppose you have a object which is sitting on the ground like this, and you exert a force F on the object, and that force moves the object from here to here. So the object was over here, it moved over here. Let's say that the displacement vector of the object is the vector d, and the object moved in a straight line. So in that case, the work done by this force is defined as F dot d, the dot product of the force and the displacement, which can also be written, as you remember from chapter 1, magnitude of the force multiplied by the magnitude of the displacement multiplied by cosine of the angle between the force and the displacement. So this angle here, theta. Notice that if you put the arrow on top of a vector, like I have the arrow over the F, it means the vector F. But if you write F without an arrow, that just means the magnitude of that vector. Okay, so this is the definition of work, and it's very important to remember that this definition only applies when two conditions hold. Number one, when the force is constant, and number two, when the object moves in a straight line. So if neither of these conditions, if these conditions don't hold, or even one of these conditions doesn't hold, then you cannot use this simple definition, right? So this definition only applies when both of these conditions hold. All right. The unit of work is a joule in the SI system. And what is a joule? Work is force multiplied by distance. So force is in newtons, distance is in meters. So Newton times meter is defined as a joule. All right. You'll see later on that joule is also the unit of energy. There's a little bit of terminology involved here. So if the force and the displacement make a acute angle, so suppose the force is like this, and as a result of this force, the object moves from here to here, let's say. So this is the displacement vector. So as you can see, F and D make an angle which is acute or less than 90 degrees. Then clearly the work done will be positive. So the formula for work is FD cosine theta. If theta is less than 90 degrees, then it's a positive number. F and D are magnitudes of vectors, so they're always positive. So that means the work will be positive then when work done is positive, we say that the work is done by the force. Okay, now suppose the force and the displacement make an obtuse angle. So force is in this direction, displacement is in this direction, and the angle between them is greater than 90 degrees. So in that case, work is going to be negative. So in that case, we say that the work is done against the force. Now, you might be wondering, if the force is acting in that direction, to the up and to the left, how can the object possibly move to the right? If you think about it, there's many ways in which that might happen. The object might already be moving to the right very fast when you started applying the force. So it keeps moving to the right for a while. That's one possibility. Another possibility is that there might be more than one force. So there might be other forces which are pushing the object to the right. So in any case, if the force and the displacement make obtuse angle, then the work done is said to be negative, and negative work is referred to as work done against the force. Okay, there's one more case. What happens if the force is in this direction and it's at right angles to the displacement? So in that case, the work done is 0. Work is f d cosine theta. In this case, it's going to be f d cosine 90 degrees, which is 0, as you know. So in that case, no work is done. So if the force and the displacement are at right angles, then the work done is 0, right? So colloquially, you can see that work is done by a force, or in other words, positive work is done when the force kind of gets its way, right? As you can see happening in situation 1. If the force is not getting its way, which is what's happening in situation 2, then we say that work is done against the force. And whichever force was pushing to the right clearly did positive work, and so that force got its way. But the force F in situation 2 did not get its way, right? All right, okay. Now, there's another important concept here, which is the concept of net work. Suppose you have multiple forces acting on an object. So let's say that you've got one force acting in this direction and another force acting in that direction. And the object moves maybe from here to here. So in that case, you can calculate a net work done. So you can calculate the work done by the force F1. You can calculate the work done by the force F2, and you can add them up, and that will be the net work, right? So let's just look at an example. Suppose this angle is I don't know, 135 degrees maybe, and this displacement is 1 meter, and let's say F1 is 1 Newton, F2 is 2 newtons. Okay. All right. So what is the net work? So let's calculate the work done by F1. So it would be force multiplied by, so the formula for work, as you know, is Ft cosine theta, right? So the force is 1 Newton multiplied by 1 meter multiplied by cosine of 0, which is 1, right? So that's going to be 1 joule. So F1 is doing 1 joule. You can see that it's coming out to be positive. That's obvious because F1 is getting its way, right? What about F2? So the work done by F2 would be 2 newtons multiplied by 1 meter multiplied by cosine of 135 degrees, because that's the angle between the force and the displacement, right? So what is that? So that's minus root 2 minus 1.41 1.41 joules. So if these are the only two forces acting on the object, the net work would just be minus 0.41 joules. So this is the net work done by F1 and F2. Notice that work is a scalar, so you don't you just add or subtract the amount of work. So it will be a positive or a negative number, and when you combine different amounts of work, you just add them up like we did over here. All right, so the net work is simply the work done by all the forces acting on the object, right? The total amount of work done by all the forces acting on the object.